use the trapezoidal rule, the midpoint rule, and the Simpson's rule to approximate the given integral with a specified value of n, and then round your answers to 6 decimal places. So we have the integral going from 0 to 3 of the function 1 over 1 plus t squared plus t to the fourth times dt, where n is equal to 6. Okay, so the first thing we want to do is we want to figure out what is delta x. So we know that a is equal to 0, which is the lower bound. We know that the upper bound is 3. And we know that n is equal to 6. So to find delta x, we know that that's b minus a over n. And so therefore 3 minus 0 over 6, which is 3 over 6, and that reduces to 1/2. So now we know what delta x is. Okay, so now what we want to do is go ahead and first solve for the trapezoidal rule. And so we have t when n is equal to 6. Okay, so let's take a look at the rule. So the trapezoidal rule is delta x divided by 2. And then we have multiplied by the function at the first point plus 2 times the function at the next x point, and so on. So let's go ahead and take a look at that. So we know that n is equal to 6, and we need to determine, okay, what are the values? So if we're going from 0 to 3, so that we know that we're going in increments of 1/2. So we're going to go from 0 to 1/2. And then 1/2 plus 1/2 is 1. And then 1/2, 1 plus 1/2 is 3/2. And then 3/2 plus 1 is going to give us 2. 2 plus 1/2 is going to give us 5/2. And therefore we have our 3. So therefore we have 0, 1/2, 1, 3 over 2, 2, 5 over 2, and 3 as our points for x. Or in this case, t, since we know that the function is in terms of t. So the formula is delta x over 2. So that means we have 1/2 divided by 2 times f of the first value, which is 0, plus 2 times f of the next value, which is 1/2, plus 2 times f of 1, plus 2 times f of 3 over 2, plus 2 times f of 2, plus 2 times f of 5 over 2, plus f of 3. And so therefore there is our formula. So what do we know about 1/2 over 2? Well, that becomes 1 over 2 times 2, which is 1/4. So therefore this becomes 1/4. Okay, and now what we're going to do is we're going to use the TI-84 to program this function and then determine this result. So what we want to do is first go into the y equals, and then we're going to put in this function. So I'm going to put in parentheses 1, or in this case maybe just start with 1 and then divided by, and then parentheses 1 plus, instead of using t, we're going to use x, so it's going to be x and then squared, excuse me, and then plus x to the 4th power, and then we're going to put parentheses around that. So therefore there is our function. Okay, And now what we're going to do is we're going to plug in this entire thing. So we're going to go now to the screen here, and then we're going to take parentheses 1 divided by 4, and then times, and then what we're going to do is, since the function is at 0, we're going to select alpha, and then where it says trace, and then we're going to select what's highlighted, which is y1, and then in parentheses we're going to put the input, which is 0, and then plus, again, alpha, trace, hit y1, but in this case we need to multiply it by 2, so it should be 2 times alpha y1 at 1 divided by 2 plus 2 times alpha trace y1 at the value of 1 plus 2 times, again, alpha, and then select y1 at 3 over 2, and then plus 2 times alpha trace y1 at 2 plus 2 times, again, alpha, and then y1 at parentheses 5 divided by 2, and then plus just the function itself, y1 at 3, and then close the parentheses. And then if we press enter, we're going to get 0.895122, and that is our result, and we're going to round it to 6 decimal places, which is that value, so we get 0.895122. Okay, so that gives us the trapezoidal rule. So now we're going to move on to the midpoint rule. So what does the midpoint rule tell us? So again, we're going at m with 6 intervals. Okay, so let's take a look at the definition. So this is delta x, which is just 1/2, and then times f at each particular midpoint. So we're going to take 1/2, and then we got to figure out what are the midpoints of each. Okay, so if we take 0 and add 1/2 and then divide it by 2, well, that gives us 1/4. And then we're going to add 1/2 to each of that. So 1/4 is now going to give us 3/4. Okay, and then 3/4 plus another half is 5/4. 5/4 plus the half is going to give us 7/4. 7/4 plus a half is 9/4. And 9/4 plus a half is 11/4. So therefore, those are the midpoints. And now we're going to take the function f at each midpoint. So f of 1/4 plus f of 3/4 plus f at 5/4 plus f at 7/4 plus f at 9/4 plus f at 11/4. So let's go ahead and approximate that to, again, 6 decimal places. So we're going to use the calculator. We already have our function in there. So again, we're going to take parentheses 1 divided by 2, and then hit parentheses, hit alpha and trace, and then y1 at the point 1 divided by 4, plus, again, alpha y1 at the point 3/4, plus the function y1 at 5/4 plus, again, the function y1 at 7/4 plus the function at 9/4, again, plus the function at 11/4, and then close the parentheses, press enter, and then we're going to round that to 6 decimal places, which is 0.895478. So we get 0.895478. Okay, and so now we're going to go and now use the Simpsons rule. So for part C, we're going to use the Simpsons rule. And so let's take a look at the definition of the Simpsons rule. So we know it's delta x divided by 3, which is 1/2 divided by 3, which becomes 1/2 times 3, which is 1/6. And then we're going to take f at the first point plus 4 times f of the second point plus 2 times f at the third point, and so on. So we're using the original values up here and just making sure that we're using the correct formula for the Simpsons rule. So we know it's going to be 1/6 times f at 0 plus 4 times f at 1/2 plus 2 times f at 1 plus 4 times f at 3/2 plus 2 times f at 2 plus 4 times f at 5/2, and then plus f at 3. And now we're going to go ahead and put that in the calculator and then approximate that to 6 decimal places. So let's go ahead and do that. So we have the fraction parentheses 1/6, and then we're going to multiply it by that function alpha y1 at 0 plus 4 times, again, y1 at 1/2 plus 2 times alpha, again, y1 at 1 plus 4 times alpha, then again y1 at 3 divided by 2 plus 2 times, again, alpha using y1 there at 2, and then plus 4 times alpha at y1 5/2, and then plus alpha y1 at 3. And then press enter, and then rounding that to 6 decimal places, we get 0.898014. So we get 0.898014, and those are results.